There's a theory that new technologies follow a sigmoid curve, starting slow, then a period of rapid growth and acceptance, and then a new normal. In 1973, senior Motorola engineer Martin Cooper made the world's first ever mobile phone call. The call was to a rival telecoms company to inform them he was speaking via mobile phone, which is frankly one of the greatest flexes in history. It took about a decade before the technology was ready for consumer use. The first cell phone was called the Dynatac, and it weighed over a kilo and was fittingly known as the Brick. In today's money, it would cost $10,000, and charging it for 10 hours would give you about 30 minutes talk time. A lot has changed. The word phone now means something very different. Sure, your device can still act like a fancy two-way radio. It can send and receive signals from whichever cell tower it's got the best connection to, but it's grown up a lot. GPS, accelerometers, face and fingerprint detection, special processors for machine learning on some phone models, and multiple cameras. There's a lot of stuff for app developers to play around with, both for useful features for their own products, and because buzzwords attract the media and the investors with money. So, let's take a closer look at a couple of the new tricks that the cell phone has learned, and at the apps that use those technologies to blur the lines between the real and the virtual worlds. From someone who knows what they're talking about, who literally has degrees in this, could you define machine learning, like compared to artificial intelligence, compared to just algorithms?
So machine learning is using statistics to find patterns in data, and then using those patterns to create basically a formula that allows us to predict the outcome or those same patterns in data that we haven't seen yet. So to get up to where I am right now, I had to take an elevator to the fourth floor. And so when you call an elevator, you just press a button. The elevator doesn't have to learn any sort of complex algorithm. There's no big data. It just knows that somebody on the first floor pressed a button, so it should go to the first floor to pick me up. On the other hand, machine learning is how your Facebook news feed is cultivated. When you like something, or when you comment on something, or when you react to something, the algorithm learns what you like, and it prioritizes those things in your news feed, even if they're from a couple days or weeks ago.
This is like when I click on one trashy thing on YouTube and suddenly my recommendations are conspiracy theories for the next 5 weeks.
Yep, it is exactly that.
One of the things I've found out while prototyping and user testing is that I need to somehow work out an interesting fact from a big block of plain text. It feels like this is something machine learning could help with. I think IBM have been doing plain text extraction with Watson, but do you think it's feasible, or do you think it's way out of my league for what I'm dealing with?
So I think it's feasible. I think developing machine learning is feasible for most average people. I will say that it depends on how you define interesting. So a lot of what goes into machine learning is the people designing it, and the decisions that they make on how to define the thing that their algorithm should be looking for. So if you're looking for an interesting fact in a paragraph of plain text information, it may make sense to create a definition of what interesting means, and then label the parts of your data with the parts that you consider to be interesting before you train the model.
So I need to be aware of what biases I'm going to bring to the table there if we're going to use that.
Yeah, and that's a problem with machine learning as a whole. We would hope that machine learning, because it's built from code and not from people, would not have biases ingrained into it. But at the end of the day, it is built by people. And those people may carry their biases into the models that they develop, either through the way that they structure the models or through the data that they use.
One of the things that I've figured is that there are technologies that get used by people, and there are technologies that get used to show off what your app can do to venture capital people with a lot of money. Can we talk a little bit about kind of the big shiny stuff that gets used, about augmented reality and things like that?
I think that people don't always realize that augmented reality is a very literal term. It really just means that it's anything added to what you're currently experiencing or seeing. And so when you have your headphones in and you're trying to get around a city and you have Google Maps in your ears, that's augmented reality. When you're trying to use that app that lets you text and see the ground in front of you so that you don't walk into a crosswalk, that's augmented reality.
What are the implications of having something that paints something on your world and maybe sends that back to its corporate overlords?
So I think a lot of this technology falls into a category that's often referred to as dual use. What that means is that it has both trivial applications for consumers, so things like Pokemon Go or Harry Potter being able to cast a spell, but it also has potential, usually military, but generally commercial applications, things where it can take information from you and use it for other uses. And so at its core, I don't know if I think that's a bad thing. I think it's fairly neutral because on one hand, it tends to improve the user experience. But on the other hand, it means that your data is probably being profited off of, if not sold to other companies, and you might not know about it, and you're certainly not gaining anything monetary from it. I think that things like machine learning, where we see issues of bias because the data that we're getting from people isn't representative of the populations that it's being used on, start to intersect with issues like privacy, where we want to get more data from those populations, and companies are sometimes pursuing not so ethical approaches to doing that. But at the same time, I think that the world we live in often necessitates giving up that privacy in order to interact with it. So you can't use Facebook without signing their terms of service, which makes you give up your rights to the data that they're taking. And that may or may not improve your user experience. But on some level, you might be locked out of the world if you're not giving up that privacy. So I think that there is a middle ground somewhere. I think it will come when companies have internal ethical standards that basically regulate how they consider the privacy of your data when they use it. I think that it'll also come when government starts to regulate new technology and data sharing a little bit more strictly. We've seen this in Europe already with GDPR. But I think that we're definitely in kind of a middle ground on how privacy and data sharing is affecting people.
This field in the middle of Yorkshire was called the most boring location in Britain by cartographers, but even as I'm standing here, my phone can add all sorts of shiny things to make the environment interesting. What stars are in the sky above me? What planes are flying past? I can find that out. Now, if I had a ridiculous budget for my app, it might be interesting to explore this. I could use augmented reality. Hold up your device, point it at something off in the distance, and it'll tell you interesting facts overlaid on the screen. Maybe you could point it at a bench and it'll tell you about the famous person who once sat there and, I don't know, invented the Hawaiian pizza. The app would look shiny and impressive, and I'm sure it would put on a decent show to get attention from the media. Or we could start adding something to make it better. Machine learning. There's a lot of potential there. From my conversation with Jordan, I reckon it's reasonably possible to train a machine learning model to determine the most interesting parts of plain text from Wikipedia articles and other sources. Heck, that machine learning system could, in theory, personalise things. Back when we were prototyping, folks loved the idea of getting facts that were personal to them. Of course, to train that model, I would have to hire people to look through thousands and thousands and thousands of articles and flag the interesting things. There's a lot of new technology to think about, a lot of new technology that I don't have the budget for. Some of those dreams are going to have to stay in the imagination. So what have we learned? Well, first up, phones now look like science fiction 20 years ago. We've come a long way from the first bricks, and you can already take advantage of a huge amount of sensors and information gathering stuff in your app. Your phone's only going to get better at understanding the world around it. Second, your phone isn't that smart right now, but it is getting smarter. Machine learning is basically just a way of getting computers to pick up on patterns. Some phones even have machine learning chips built in. You can train the model beforehand and then run the recognition part at least, lightning fast on the phone. That can help solve a lot of real-world problems if you've got the time and the budget. And finally, your phone is not just a screen, but it's part of your world. Augmented reality is taking your phone from a flat screen to something embedded in the way you see the world, or at least it will eventually. Google Glass did use it, Pokemon Go blew up because of it, and it really does have interesting implications outside of gaming. But more importantly, everything we've talked about, they're the sort of shiny bells and whistles features that can mean good publicity for the thing you actually want to make. Next up, how to connect your app to the cloud.